Good morning to one and all. My name is Janvi Murani. I am from MVP's KBT Story, Nasik. I am going to brief you about information retrieval for geographic data. Let's begin. Let's talk about information retrieval. Information retrieval system is a software or a hardware system that helps user to retrieve the information or gain access from a large amount of data or such as documents, web pages, or other databases. In short, the information retrieval is a process or the technology involved in storing, structuring, analyzing, searching, and retrieving information from databases or other diverse collection of data. The primary goal of information retrieval system is to effectively and efficiently find the relevant information in response to a user's query. The IR systems are widely used in various applications, such as in web search engines like Google, Yahoo, Chrome, etc. They are also used in document retrieval system like in libraries, in e-commerce recommendation system, and any enterprise search tool, etc. They play the crucial role in helping the users to gain access and make decisions from the vast amount of data which is available in digital form. Now, what is geographic data? Geographic data is also known as geospatial data or spatial data, which refers to the information which is concerned with specific location on Earth's surface. It includes data about the physical and human-made features of the Earth, such as natural landscapes, cities, roads, rivers, and more. It also includes the data related to various geographic attributes such as population, climates, and the land use. Geographic data is used to represent and analyze the spatial characters of the world, and it plays a crucial role in various fields like including geography, urban planning, environmental science, and geospatial technology. It also helps us to understand and analyze the spatial relationship between different features and make informed decision with the help of the information we gain. Types of geographical data. First is geographical coordinates. Geographical data often includes latitude and longitudinal coordinates of a specific location on Earth's surface. These coordinates are measured in degrees and can be used to pinpoint any place in a globe. Second is vector data. This type of data represents geographical features such as points, lines, and polygons. Points can represent individual locations on the globe, while the line represents a linear features like rivers or roads, and a polygon represents an area like land parcels, administrative boundaries, or bodies of water, etc. And the third type is raster data. Raster data represents the Earth's surface, such as grids of cells or pixels. Each pixel contains information about a specific geographical location. Raster data is commonly used for like satellite imagery, digital elevation models, and remote sensing data. Then, topological data. Topological data represents the spatial relationship between the geographical features like rivers, bodies, or many more. It defines how the features are connected to each other. Like we can define with the help of topological data how roads intersect or how administrative boundaries of countries or continents overlap to each other. Then it is remote sensing data. This data is collected from a satellite or any aerial sensors or device and can include imaginary or imagery, temperature readings, and any other measurements. Remote sensing used for tasks like monitoring environmental changes, land use planning, and disaster management. These are the types of geographical data. Now, let's see what is information retrieval for geographical data. Geographical data information retrieval. It is a specialized field within the information retrieval that focuses on searching, retrieving, and managing geographical data. It combines the principle of information retrieval with Geographical Information System, that is GIS, to help users to find relevant geographical information based on the spatial and non-spatial queries. In short, it is a smart system that helps you to find specific location or specific information about a place. It combines map and data. This system is used for searching places, finding a data about a place, sorting the results based on the place and the features, maps, and many more. It can be GIR is used in everywhere, like finding nearby shops, services, planning city layouts, and many more things. What are the key aspects of GIR? The aspects of GIR are: first, the spatial queries. In GIR, user often perform spatial queries which involve searching for a data based on their spatial characteristics. Let's see, for example, user might search for all the restaurants within a 5-mile radius of a specific location. All land parcel with a certain land use category within a city. These all are the spatial queries, and this is one of the aspect of GIR. Second is keyword queries. GIR system can also handle keyword based queries similar to traditional information retrieval system. User can enter the text-based queries and the system will retrieve the geographical data relevant information to their search terms. Then is geospatial indexing. To make the spatial query more efficient, GIS system use geospatial indexing technique to organize and retrieve geographical data. These indexes allow for quick retrieval of data based on the spatial attributes such as point, lines, and polygons, that is, their vector data. Next is Next aspect is relevance ranking. GIR system use ranking algorithm to prioritize the search results based on both the spatial and non-spatial relevance of the data. The ranking may consider factors such as proximity to the user's location, attributes, relevance, and other criteria. Now, next is geographical attributes. The geographic data often includes non-facial attributes such as the name of the location, population data, business information, and many more. In this, the GIS system considers these attributes when determining the relevance of results. With this, the efficiency of the GIS system increases to a greater extent. And lastly is the location-based services. Geographic Information Retrieval System is closely related to LBS, that is location-based services, where users current, or specific locations are used to provide them with the relevant information, such as nearby restaurants, traffic updates, or local businesses. Now, let's study the architecture of GIR system. In this, in the slide given, first, the bottom part of this architecture, it is the index construction workflow, which consists of three modules, that is document abstraction module, the index structure, and the index construction module. The processing services here up in the middle of the figure, the geographic space ontology service used in the spatial index construction is on the left side, and the service used extensively in the index construction module. On the right hand side, one can see the two services that are used to solve the queries. The rightmost one is the evaluation service, which receives queries and uses the index structure to solve them. The other service is the web map service, following the OGC specification, that is used to create the cryptographic representation of the query result. A geographic information retrieval module is in charge of coordinating the tasks performed by each service to respond to the user's request. The uppermost architectures are the two user interfaces that exist, that is administration user interface and the query user interface. Now, first, geographic data comes from various sources, including government agencies, commercial mapping providers, open data initiatives, and user-generated contents. M- Data may be as maps, satellite imagery, addresses, geographic coordinates, and many more. uh, Before storing this data, the data has been processed. As the data is in various form, for consistency and accuracy and compatibility of the system, the data has been processed. In this, the geocoding services may convert the textual addresses into geographical coordinates, that is, converting non-spatial data into spatial data. Data validation and cleaning processes are often applied to remove the inconsistency in the database. Here, the geographic data that stores and manages the geographic data efficiently, which also support the spatial indexing for faster retrieval. For example, it includes Oracle Spatial, MongoDB with geospatial capabilities, PostgreSQL, etc. These are the geospatial databases which can be used for storing geographical data. Then, after the documents or data is stored in geographical data, the index construction is done. The index construction is done either by indexing, like spatial indexing or textual indexing. Spatial indexing techniques includes like R-tree, quad-tree, organize the geographic data for efficient retrieval. This indexes speeds of the spatial queries. Then there are many processing services included in this architecture. In this architecture, as the query handles both spatial and non-spatial data in nature, so it has to retrieve the information in spatial form only. So ranking and relevance scoring is done in this retrieving process. That is, when users submit queries, the system ranks the search result based on the relevance. Algorithm consider the spatial proximity, attribute matching, and other criteria. And many services are used like geometric supplier services, gazetteer service, web map service, and query evaluation services, which are used, and the main it is administered by Geographic Information Retrieval Module in the processing services state. Next, at the top it is user interface. User interface consists of administration user interface and query user interface. The user interface provides a way for user to interact with GIR system. It includes map, search boxes, filters, refining research results, etc. Web-based interfaces and mobile apps are the common ways to access the GIR system. This is the architecture of GIR system. Now, what are the technologies used in the GIR system? First is Geographic Information Retrieval System. Sorry. First is Geographic Information System. Geographic Information System is a software is central to GIR. It is used for storing, managing, and analyzing geographic data. It allows for the creation of maps, spatial analysis, and data visualization. The popular software includes are QGIS, ArcGIS, and open source options like OpenLayers and Leaflet are the most popular open source for GIS system. Next technology is spatial indexing. Spatial indexing Spatial indexing includes the techniques like R-tree or quad-tree to create the spatial indexes for efficient searching and retrieval of geographical data. It is used to optimize the retrieval of the geographical data. Then it is web mapping tools. Web mapping tools such as Google APIs, Mapbox, and Leaflets allow developers to integrate maps and location-based services into webs and mobile applications. Then it is geocoding services. First of all, geocoding is the process of converting non-spatial data, that is, for example, street addresses, location, name location, etc., in geographical coordinates, that is, latitude and longitude, which is measured in degrees. Services and APIs like Google Maps, geocoding API or OpenCase geocoding that convert the address, name, location into geographic coordinates. These are the tools used for geocoding in GIR system. These are the various technologies used in GIR system. There are also open data sources like government, organizations, and communities provide open geographical data sources that are freely accessible and can be used for various purposes. For example, OpenStreetMap, USGS. These are the examples of such sources. GIR can also be used with the help of cloud services, for example, Amazon, Microsoft Azure, Google Cloud. They often offer the scalable and cost-effective solution for storing, managing, and analyzing geographical data. This is also a predominant solution for use of efficient use of GIR system. Next, there are various applications of GIR system. It is used in various industries and fields. First, it is used in navigation and location-based services. It is offer like finding nearby places, gas station examples. These are the examples of navigation and location-based services. Secondly, it is used for environmental monitoring and conservation. It is used for monitoring natural resources, tracking deforestation, and managing wildlife habitats. It is also used in agriculture and precision farming. Farmers uses GIR to analyze the soil data, weather patterns, and satellite imagery to optimize the crop planting and harvesting. Precise agriculture relies on GIR for precise resource allocation. Real estate and property management. Real uses this field uses GIR to help clients to find the suitable properties. It provides the property values, neighborhood characteristics, and etc. Market analysis and retail. In this, businesses uses GIR to obtain the information like customers' demographics, traffic, competitions, location based on which the decisions can be made. It is also used in tourism and hospitality. It is used to develop informative travel guides and apps. It is also used in natural resource management, like it we use for managing the forest, fisheries, and mineral resources. Emerging response and public safety. It relies on the locating incidents, coordinating responses, and managing resources during the crisis. It also helps to navigate to accident and disaster sites. It is GIR plays an important role in census and demographics. Government uses GIR for conducting the census and geographic demographic studies. Geospatial networking and location sharing apps. It also uses like to tag posts and photos with users. Using geographic location is possible with the help of geosocial networking. And lastly, it is geospatial intelligence. It is an integral to national society, security, and military operations by providing geospatial intelligence for defense and security. These are the applications for GIR, which makes the GIR retrieval system across a wide range of industries for in decision making, effective resource management, and improved services for individual communities. And lastly, what challenges does the GIR system face? The first challenge is data quality and accuracy. The geographic data must be accurate and up to date. Incorrect data can lead to unreliable results. Data quality, especially when the crowdsourced or open data is concerned. This is the bigger challenge. Next is data integration. As we know, the data comes from various sources with different formats and structures. So this makes it complex. So data integration is crucial for effective and efficient GIR to work. Next is geocoding and address standardization. Geocoding Geocoding accuracy can vary, impacting the search results. Standardizing the addresses across different regions and countries can be challenging. Cross-border and multilingual issues. GIR system must be capable of handling geographical data from various countries, languages, and character sets, and they need to be sensitive to cultural differences. And lastly, it is privacy and security. As the data about the country is being shared, concerns about the priority and security. Unauthorized access to the geographic information of an individual or anyone can lead to the privacy breaches and misuses them, and that can cause trouble. These are the challenges of GIR system. So this was all about GIR system. Hope you understand the briefing about the information retrieval for geographical data. Thank you.